Welcome everyone to the mechanics class. This is our last session, uh, mostly dedicated to the problem solving. Uh, Before we jump into the solving the problems, I would like to give us glimpse of what syllabus we have studied in this subject. So let me start it. Okay. So in engineering mechanics, we broadly classified into two parts. One is statics part, another one is dynamics part. In statics part, um, we initially started with the very basic things such as equilibrium. When we say a system is in equilibrium, how to calculate the resultant, law of different laws such as law of parallelogram of forces, triangle of forces, then law of polygon of forces, and yeah, etc. We have also studied Varignon's theorem. We have also studied principle of transmissibility of force. Okay, so these basic laws, I will say, we in with this we have started and understood what is force systems, different force systems. Okay, in this we understood the difference in between coplanar and non-coplanar force system, then what is collinear and non-collinear force system, and combination of this coplanar and collinear. Okay, with coplanar, so basically coplanar concurrent, coplanar non-concurrent, non-coplanar concurrent, non-coplanar non-concurrent. Okay, but our focus is mainly on the coplanar force system because we are dealing with the problems which are for this exam which can be drawn on a two-dimensional paper. So it's mainly a coplanar force system we have to we studied throughout our subject, and in that it can be a concurrent force system or it can be a non-concurrent force system, and we understood which equations of motion we should apply if we have a concurrent force system and if we have a non-concurrent force system. Okay, we also studied the concept of resultant, how to find the resultant in both coplanar concurrent and coplanar non-concurrent force system, how to decide its location, how to at what angle the resultant will come. So all these things we have studied. Okay, and then we brought a topic of friction, and mainly we studied here what is the difference between static and kinetic friction or dynamic friction. Okay, um, uh, and how much will be the maximum frictional force, what is angle of friction, what is cone of friction, and how to deal with the problems in which friction is involved. Okay, in which we have, let's say, a block which is kept on a horizontal surface or inclined surface, or problem with the pulleys and ropes, etc. Okay, or string is attached to, let's say, box or something. So all those kind of problems we understood. We also understood special cases such as when friction comes with not just surface but with pulleys, how to deal with the different tensions, and what is the relationship between the high tension side and low tension side. Okay, so that's the overall idea about the friction, and then at the end we also studied a concept of trusses. Okay, In trusses, we studied how we can generate a truss structure. What is truss structure? How can we generate it? How can we find the number of joints in a uh, given truss structure? And what are the methods to calculate the forces in the members of truss? So we studied basically two methods here: method of joints, and method of sections. And we also know that in which situation we should go for a method of joint and in which situation we should go for method of sections. Okay, so basically if a truss is smaller, a single truss or two trusses are there, then maybe we can go for the joints. But if a larger truss structure is there, and if they are asking a force in a member which is, let's say, maybe at the center of it, then if we use the method of joints, it will be time consuming. So in that case, we can go for the method of sections. Okay, and the last topic which we have studied in statics was the principle of virtual work. Okay, we studied it at the end, but it is mainly related to the statics part because body is in equilibrium and we are assuming a virtual displacement, and work done by the virtual displacement, we called it as a virtual work. And the principle of virtual work, we applied that sum of all the virtual work is zero for any virtual displacement, and assuming that we have calculated the forces and moments. But yeah, you already know that we can do the same by equation of equilibrium as well. We don't need virtual work principle exclusively. So it's not a compulsory topic, right? And then that's all we studied in the statics part, and we have solved problems on each and every topic. In dynamics, as you know, I have given initially a brief introduction about the law of basically Newton's law, and the first law, second law, and third law. Also the um, how the equations of motions will look like, how we can derive them. Okay, and we also understood that dynamics we can split into two components or split into two groups as kinetics and kinematics. Okay, mainly the equations of motions and all we used in kinetics part, where we were dealing with the displacement, velocity, and acceleration. We understood how to calculate these things: displacement, velocity, acceleration in constant acceleration and variable acceleration problems. Okay, we understood that these equations of motion we can apply only when the acceleration of the system is constant. Otherwise, we have to um, calculate the velocity acceleration by the either differentiation or integration depending on what they are asking. Okay, so this is in this part we have also studied. So basically we studied the linear, and we also studied the circular motion or fixed axis rotation, you can say, circular, and projectile motions as well. Okay, so if you remember, we studied the projectile motion to understand um, if we throw any particle making some angle with the horizontal at certain velocity, how can we find the velocity after certain time? How can we find the maximum range of the projectile, maximum height the projectile reaches, or at what time the projectile will reach the maximum height, or the total time travel of projectile, okay, etc. So all these things we have studied for the curvilinear motion or projectile motion. Okay, in circular motion, if you remember, we studied the different component of accelerations, that the acceleration cannot just is the tangential, but also normal component of acceleration will come because of the change in the direction. So velocity direction is goes on changing. So ultimately we'll have a one component which is towards the center, and we called it as a normal component of acceleration, and we derived how total acceleration is um, square of total acceleration equal to the square of tangential component and normal component of acceleration. Okay, and we have solved problems and on all of these topics. Okay, so all topics are equally important. um, then I have also given you some basics of, let's say, instantaneous center um, concept. um, I hope this topic will be covered again, maybe for some of you in the theory of machines subject, especially for the students. But there you will mainly focus on the instantaneous and applying this instantaneous center method to find the velocities for the mechanisms such as single slider crank chain mechanism or four bar chain mechanism, etc. Okay, but yeah, um, if you for hero students, I think whatever we have studied here, it's enough. Like if you have basic idea about the instantaneous center, you should be able to solve the general problems. um, okay, and then we studied kinematics part. Sorry, this is all about the kinematics, and then about the kinetics. In kinetics, we know we include the forces, um, or the motion is analyzed considering the forces causing the motion. So mainly we worked on the D'Alembert's principle. D'Alembert's principle, um, work energy principle. Okay, so in this we understood the concept of what is work, what is energy, what is law of conservation of energy, and how uh, work done can be written in terms of change in kinetic energy of the system. Okay, and we have solved many problems on it. Later we also understood the concept of impulse momentum. Okay, here we understood the concept of impulse momentum, law of conservation of momentum, and how the relationship between the impulse and momentum, and we solved the problems. We understood the concept of collision. Okay, and in this collision we mainly use the law of conservation of momentum. We also studied what will happen if completely elastic, then plastic, or partially elastic collision happens. What will happen to the coefficient of restitution, and how the equation of momentum will look like. Okay, and we studied the problems in combination of all of these. So you should be able to know, like, if problem comes in exam, how should you tackle it. If it is all about the acceleration and forces, better to go with the D'Alembert's principle, because in that acceleration is there, because we make a body which is in motion in equilibrium, or we in a dynamic equilibrium, by applying the inertia force, which is an imaginary force, up in the direction of opposite of the motion, um, to apply the equation of equilibrium, and then we solve the problem. So whenever acceleration comes in the question of uh, this kind of kinetics problems, when which force system is involved, better to apply D'Alembert's principle. Okay, whenever you deal with the displacement of a body, okay, when distance traveled by the body, these terms are involved, then from that you can calculate the work done. So in those situations you can use the work energy principle. Okay, and whenever the impulse is mentioned, okay, that is the force applied for certain times for short duration in those cases, or also whenever there is a collision is there, impact is there, you can go for the impulse momentum principle. Okay, so depending on the problem, you should be able to decide what method you should apply in these cases. Okay, and at the end we studied Lagrange equation. um, okay, in Lagrange equation we have understood what is Lagrange approach. Hello, am I audible to all? um, yes. Dharmesh, could you please check? You can maybe disconnect and connect back again. Yeah. Okay. We will continue. We understood the concept of Lagrange approach, how it is different from Newtonian approach, and how the energy formulation can be used here to calculate Lagrangian L. And from that, how can we create equation of motion for a given system? And I suggested you to use this approach in cases where like you have the, let's say, spring mass system. Okay, in those cases, or whenever the um, yeah, vibration related topics, whenever they are asking you to find the frequency, okay, natural frequency, then you can, let's say, create equation of motion, and by using Lagrange equation, and you can find it out. I hope this topic will also be covered um, during your vibration topic. That whenever you study the vibration, I hope you'll first study the how to, what are the different types of equations of motion. Okay, force system, force vibration, free vibration, for example, then damped and damped vibration, and then how to how the equation of motion will look like in those situations and how to create it. Okay, and one of the method is Lagrange equation, or Lagrange approach for it. But if it is not, you are, if you are studying any other method, but just keep in mind that this is also the method which you can use to calculate the uh, natural frequencies, create equation of motion. Okay, and for your information, this can also be used for 2D, two-dimensional systems as well. Okay, what we have studied is one dimension system where we have let's say uh, 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 displacement x, for example, but not the other this displacement we have considered, maybe let's say theta in combination of displacement. But in this using this, you can also solve those kind of problems. Okay, um, this is just for your information, but from the mechanics point of view, I think you will be using it very limitedly, only in the problems where they are asking the um, equation of motion. But I hope you will study it in more detail when you study the vibrations topic. Because it's common for both the branches. You will study there again. Okay, but we have anyway studied all the problems which are possible in mechanics, so that you can correlate how the approach is different in Newtonian and Lagrangian approach. Okay, we have studied the problem of simple, let's say, ball is dropped down from certain height, or a simple pendulum, spring mass system, and a pulley system where both mass are attached to the two side. Okay, so this is the overall subject. Okay, we have studied, and I have also given you introduction of let's say polar form when we studied the kinematics. Okay, that time we have also solved problems not in just linear but also in polar coordinate system, and things are same. Like whatever equations we are using here, same equations will be applied in the polar form. And we also solved some problems in that coordinate system as well. Okay, so uh, so keep revising the subject regularly after a few months, since you have a very huge gap of like close to 10-11 months before exam, and you should uh, revise it regularly, maybe after 3-4 months, just to um, be in touch with the subject. Okay, and continue solving the question. Okay, what I'll do is I have collected some questions which we'll solve today, and also I'll send you some questions regularly through WhatsApp group. Okay, so that's what we will follow the process. Yeah, but even if the subject is completed, you can make use of our WhatsApp group in order to solve the question, or ask your doubts. Okay, even if you feel like this question is interesting and others should also try, you solve it, and you are also able to solve it, but you can also free to post it in group. Okay, so that it will be helpful for others as well. So let's start with some questions. Okay, I have brought some questions from statics part, because it's been a while we studied the statics. So, and we have studied uh, dynamics questions comparatively a lot. So it would make more sense to focus first on the statics questions. Okay, I'll expect quick answers here, since you are already aware of this topic. Okay, little bit, let's say, tricky questions I am putting. At least 2 to 3 questions will be tricky. So let's start with them. What I want is you should be able to draw the free body diagrams correctly. If you are able to do it, then the problem is very easy. Compute the force F. Required to just start. The lawn roller of diameter 600 mm and weight is equal to 1 kilonewton over a 75 millimeter step when the roller is pushed as shown in figure. Okay, what is so this is first part of the question. Second part of the question is uh, magnitude and direction magnitude and direction of reaction of the step on the roller. Okay, so quite interesting question. Yeah, assume this as the roller. Okay, This is the handle of the roller. We are applying a force F, which is at 30 degree with the horizontal, and the diameter is 600 mm. The radius is 300 mm. Okay, so total is by 600 mm. Diameter is 600 mm. Okay, and it is on the step. I'll use the okay. So the step is okay. So this is step is 75 mm. 75 mm step. Okay. And we don't know at certain angle. Let's say it is connected here. So yeah, I think yeah, other things you should be able to do it. I'll not give more hints here. That is all is given in the question. Weight of the block is W, that is 1 kilonewton. Weight of the roller, sorry. Okay. You can call this point as A, and you can call this point as B. So I'll give you 2 minutes of time, and you come back with your answers. Though it looks complicated, it is not that complicated. Okay, if you think it correctly with the approach of solving using the equations of motion, you should be able to solve it easily. Okay, first question they are asking is F, which is required to just start the lawn roller. And the second question is magnitude and direction of reaction of the step. So if you are able to solve the first one, others are quite easy. Or maybe you can calculate it them together. Yep. Yeah, anyone? No? Okay, let me help you out with this. So if you I'll use the green pen here to draw some lines. Okay, so I draw this angle alpha. So if you think this height is 225, since the total height of the center from ground is 300 minus and so yeah, we have to subtract the 75 from it to get this 225 mm. So we know this height, we know the radius of the roller, so you can calculate the alpha angle. What is sine of alpha? So let's call this point as D. Okay, so sine of alpha is equal to BD by the center is, say for example, C here, BC, BD by BC. So it is 225 divided by the 300. No, Abhishek, 6 Newton looks very less. It's not correct. So you will get around 0.75. So alpha is sine inverse of 0.75, and that is 48.59 degrees. Okay, so this is the alpha angle. So if I draw now the free body diagram of that joint of the point B here, okay, look at it, how it will look like. So we have um, the point B like this here, okay, and at point B, what are the things? We have certain force F, okay. Uh, oh, no, this is not point B. We'll start at point C first, and then we'll come to point B if required. So that point C, we have the force which is acting at an angle 30 degree. We have self weight of the roller, which is W, that is 1 kilonewton. Let's call it as W, it says P, sorry, F, and then we also calculated now RB will be the reaction. Okay, RB will also be one reaction, and this is making an angle, certain different angles. Okay, and this is 48.59. Is it correct? Is it correct representation of the forces? Any doubt till this? Okay, and then if it is correct, can I also make it like this? Okay. So this has a 30-degree angle, and this has which is 48.59 alpha, and this has a weight. Okay, so this is our RB and this is F. Okay, by using the law of transmittivity of force, and now by using Lami's theorem, um, using Lami's theorem, I can say RB is equal to, sorry, RB divided by sine of 60, because this angle is 60 now. If this is 30, this has to be 30, is equal to F divided by sine of 90 plus alpha, or 90 plus 48.59, and that is equal to W divided by 180 minus 30. So this is complete is 180. 180 minus 48.59 plus 30. So sine of 180 plus 30 minus alpha, which is 48.59. Correct? And now Think on it. What is unknown here? We either have to calculate RB or F, or on W is known. Um, so W is how much? 1 kilonewton. So yeah, then you don't need anything else. You, by using this relation, you can also calculate F and RB. How the F will look like? F will be equal to 1 into sine of 90 plus 48.59 divided by sine of 180 degree plus theta is again, or let's calculate it. You should get 210 minus 48.59. Calculate in using calci, should get 2.075 kilonewton. Okay. And what about the RB? Is 1 into sine of 60 divided by sine of 210 minus 48.59. Okay. So it's 0.866 divided by 0.319, close to 2.72 kilonewton. Is it clear, Abhishek? Are you following? Any doubt? Because none of has answered this question. It's not that difficult. You should be able to at least draw this free body diagram, and then I'm doing nothing here, like just applying the Lami's theorem to solve it. If you don't want to use Lami's theorem, you can also use the equations of equilibrium and solve it. Are you following? Any doubt? See, don't just get afraid if question, let's say, comes like this, and not in the form of force system. Okay. It is actually indirectly given in the form of force system. So it's you should apply your basic understanding to check how can I convert this problem to the force system. Okay. Yes, Ganesh, I'll explain you once again. Okay. Let's okay. So if you are taking moments about F, then actually it is becoming very difficult to solve, Abhishek, because you don't know the perpendicular distance between the line of action of the force F and the point B, and it's difficult to calculate, right? So you can, it will be difficult to calculate the moment because of the force F about point B. So yeah, we can calculate. I am not saying we cannot, but it is not the smart approach, I would say. Okay. Because it will be time consuming if you use that. Okay. So you should think of the ways which can make it, let's say, a little bit simpler. Okay, fine. Let's I'll explain this problem once again. What they're asking is here is this force F required to just start moving the lawn roller of this diameter 600 mm and weight 1 kilonewton over a step of this 75. Okay, so we are actually assume that the roller is kept here. Okay. In order to just move this, if I apply small force, obviously I'll not be able to move the roller above this step, because step is restricting the motion because of the reaction by this surface on the roller. Okay, so I have to overcome that reaction. um, by applying certain force in this direction, because my handle is at 30 degree, so which I cannot change, and by assume that at that 30-degree angle itself you have to apply certain force in order to start moving it. Okay, so it's a practical problem. So yeah, we have to first calculate this f, and also we have to calculate how much is the reaction, and at which, in which direction the reaction by this step is given on the roller. Okay, so yeah, so in order to calculate this angle of reaction, I just mentioned it as alpha. Alpha will be, sine of alpha will be perpendicular divided by hypotenuse. Perpendicular is BD, hypotenuse is BC. You'll get the alpha. So at this alpha angle, okay, 48.59 degrees, you will have a reaction from the um, step to the roller. Okay, and that is not along the line of action of 30-degree force. Okay, so 30-degree will force, Abhishek, will create a motion, create a moment, but yeah, you have to, let's again draw the line of action and then calculate the distance, perpendicular distance, and uh, make the calculation, which is time consuming. Okay, but if you know the angle, if you know the reaction, the best way is to know, like, yeah, uh, you have the 48 point, you have an force or reaction which is at angle 48.59 passing through the origin or the center, and we already have two forces which are passing through center. So the force system will look something like this. One force which is applied by us, okay, applied by the user on the roller. The weight is the weight of the roller, and RB is a reaction by the step. I have just redrawn this figure like this, okay, by using the principle of transmittivity of force. So RB I can draw from here like this, F I can draw from here like this, and W as it is. And now just I use the Lam's theorem to solve it. Okay. So RB we have calculated, that is a reaction because of the step, and F also we have calculated, that is a force we have to apply in order to start moving this roller. Ganesh, is it clear? Okay, problems are simple. Just you have to convert it into a free body diagram correctly. Okay, I'll give one more question, little bit tricky again. I would expect like you should be able to deal in this question um, easily. The identical rollers, the identical rollers, each of it 50 Newton, are supported by an inclined plane and a vertical wall, as shown in the figure. We'll stop. Okay, find the reaction. Find the reactions at the points of support A, B, B and C. Okay, A, B and C. Assume all surfaces to be smooth, so you don't consider friction here. Okay, let me draw the diagram. Okay, two rollers are there of weight 50 Newton, identical rollers. Okay, 50 Newton identical rollers supported by an vertical plane, inclined plane, and vertical wall. Okay, this is the vertical wall, and this is the inclined plane. Okay, this is point B. This is point A, and this is point C. Okay, and this angle of inclination is 30 degree. So solve this question. You can take this point as point D. Okay, solve this question. First of all, think how the force system will look like. Okay, try to solve it in a smart way. Draw the free body diagrams, and then calculate these reactions at support A, B, and C. Okay, I'll wait for 2-3 more minutes, and you solve this question. So think on this, whether it's a coplanar concurrent force system or coplanar non-concurrent force system, and like how can we make it more simpler and solve it. Anyone? Okay. We got two answers here. 57.73 is for RB, and 28.86 for RC. Ravi from Ravi Teja. No, Ravi Teja, something is mm, wrong here. Okay, think of it again. Yeah. Otherwise, yeah, I'll help you to solve it. Yeah, I think let's solve it now. Okay. Yes, RC is 25. Right? No, so no. Mm, 57. Okay, who was it? 57.73 is RB. Okay, let's solve it. Maybe you are using some other names or something, but yeah. Your answer looks okay, Ganesh, but 43.3 is for RA, not for RC, and 25 is the RD. Okay, so maybe looks like we have to solve it in detail to clarify it. Okay, so let's start with the freeboard diagrams of the rollers. First roller, okay, it looks like this. We have a 50 Newton force acting like this. Then we have this is second roller rather. Okay, because we have less forces here, so we'll start with the second roller. We have A and RD only. Okay, RD, and we have RA. Okay, you have to find the angles. That is the main point here. Mm. So if angle between two lines is 30 degree, then angle between their perpendiculars also has to be 30 degree. So considering that this angle has to be 30 degree, so this has to be 60 degree. Okay, I hope you are following this till this. Similarly, if so, these two lines should also create a 30-degree angle with horizontal. So RD should make a 30-degree angle with horizontal. So this angle has to be 60 degree. And here we have 90 degree, and here we have 90 degree. Is it clear till this? Any doubt? Am I audible to you all? Can you hear me? Hello? Yes, okay. Abhishek, could you please check the connection? Maybe you can log out and log in again. So yeah, this is RD and this is RA. And now if I use the Lami's theorem here, 50 divided by sine of 90, because sine 60 plus 30 is 90 and sine 90 is 1. That is equal to RA divided by sine of 90 plus 30. Sine 90 degree plus theta is cos of theta. Or sine 120 you can directly calculate using calculator. RD is equal to RD divided by sine of 90 plus 60 degree. Okay, so from this you can easily calculate RA and RD. This is 1 anyway, so it is very easy to calculate RA. RA is equal to 50 sine of 120. So it is 50 into 0.866, so it is 43.3 Newton. Okay, so 43.3, Abhishek, yes, RA is correct. Ganesh, so RC is not equal to 43. Okay, so check your answer. What about the RD? RD also you can calculate. RD is equal to 50 into sine of 150. Okay, and that is 0.5. Sine 90 degree plus theta is cos theta, and cos 60 is 1 by 2. You can say 25 Newton. Okay, so we got RA from here. That's but RB and RC, if you want to calculate, you just have to create one more free body diagram for the second roller. From this, what we have calculated is RD, and that will help us there. Okay, so you can either draw the free body diagram of, let's say, whole system, or you can also draw the free body diagram of the structure. Okay, maybe let's start with the first free body diagram of the lower roller. Okay, RD was like this, making an angle 30 degree. So this is 60 degree. We have an RB making an angle 30 degree. This is 60 degree. We have RC horizontal, and we have 50 Newton force vertically downward. Okay, so here we cannot apply Lamè's theorem, but we can calculate the summation of all vertical forces and horizontal forces and equate it to 0. Okay, so summation of all vertical forces equal to 0. The vertical forces include minus 50 minus RD sine of 30 plus RB sine of 60 is equal to 0. Okay, and here what you will do is RD you have already calculated, that is 25 minus 50 minus 25 sine of 30 plus RB sine of 60. Okay, so from this you should be able to calculate the RB. RB will be equal to 50 plus 12.5, 62.5 divided by sine of 60 root 3 by 2, so it is 72.17 Newton. Okay, you got RB value as well. If you do the summation of all horizontal forces equal to 0, then minus RD cos of 30 minus RB sine of cos of 60 plus RC equal to 0. RD is 25 minus 25 into cos 60 is 0.866 minus RB is we just calculated 72.17 into 0.866 plus RC equal to 0. So from this you can calculate RC, which is 57 0.735 Newton. Okay. Abhishek, yes, RC and RB, you understood. Srijana, looks like some. Sonu, you guys have answered it incorrectly. Now is it clear to you all? See, once the main problem, 80% problem is solved once you are able to draw the free-body diagram. After that, there is nothing. There is just a mathematics. I'm not doing nothing after drawing the free-body diagram. It is just summation of all the forces in horizontal direction, vertical direction equal to 0. And and in this case, I applied Lamy's theorem. That is same thing. Okay, nothing different. Okay, one more interesting question I'll give. Um, okay, these are like some good questions to build your thinking on creating free body diagram. Okay, because I would think like statics problems can be solved if you know, if you are able to draw the free body diagram. So you should think of some variety of problems. Okay, so here you should be able to easily tell at what angle this RD and RA will look like, will come here, at what angle RB and RD will come. So just by looking into the figure, you should be able to directly draw it and then solve it easily. Okay, it comes with solving problem, otherwise it will take some time and ultimately you will be able to solve, but it will take time. Okay, so um, keep practicing. Mm, okay, let's take one more question. Two cylinders, A and B. Okay, again one interesting question, are connected by a rigid bar of negligible weight hinged at each cylinder cylinder as shown in the figure. Determine, first question is determine the magnitude and force P required to keep the system in equilibrium. Okay, oh, okay, no, that is only question. Determine the magnitude and magnitude of force P required to keep the system in equilibrium. Okay, these days a lot of questions are coming without options. Okay, and if you don't have practice of solving the problem, there is a chance that you can make a silly mistake. Okay, if you have the option and if you are unable to achieve that option, any of the four, you know that you are doing something wrong. But if they are giving a question where you have to type the answer, there is no way to trace your mistake. Okay, if you do a small mistake, it can affect it. Okay, so I would suggest you to focus more on practice now, so that as you solve more and more question, your tendency to make mistakes will reduce and accuracy will increase. Okay, so that is the main thing. So we have two cylinders, so these are the One cylinder is kept on this 60 at a 60-degree inclined plane. Okay, and another cylinder is kept somewhere here. Yeah, like this. uh, this is A and cylinder B. Okay, and they are making an 15-degree angle with the horizontal, and it is 80 centimeters. Okay, I'll repeat the question. The two cylinders A and B connected by a rigid bar of negligible weight, 80 centimeter long it is, okay, as shown in this figure, and that is making an angle 15-degree with the horizontal. Determine the magnitude of force P required to keep the system in equilibrium. So I'll show you how the force P looks. Force P is making an angle 70-degree with the vertical. Okay, this is already given in the question. You have to calculate the magnitude of force P. WA is the weight of the cylinders A and B. And WA is 600 Newton. WB is 400 Newton. Angle is 15-degree. Shrujana, this angle is 15-degree maybe, and this is 70-degree here. Okay, here this angle is 45. That is why the difference 15 is coming. Okay, I hope it is clear. More or less things I have already given you, all the things. So you should be able to solve it now. Okay, I'll wait for a couple of minutes. You solve it and send me the answer. Okay, so these questions are like not traditional questions in exam. Okay, maybe um, it, but these are very good questions. It will build your understanding of drawing the freeboard diagram. Some of them are previous years, but not all of them. But if you are able to solve this, means you are good at drawing the freeboard diagram, and if question comes anything like this, then you should be able to handle it. Okay, you will get easier questions than this, but this will bring knowledge to you. Yes, whenever we are supporting Punya, obviously the reaction will come because weight is acting on the uh, that inclined surface 60-degree and 45-degree. Obviously some reaction will come out of there, so you have to consider the reactions from support. Are you able to draw the free body diagram? Okay, let's solve it. Um, so first of all, draw the free body diagram of this left hand side cylinder, which is at an angle 60 degree. You can parallelly solve if you already solving it, and share your answers in the chat group. Okay. um, okay. So we have one force which is at angle at 60 degree, because the angle between the perpendiculars has to be equal to same when the angle between the two lines is 60, the perpendicular has to be 60. Okay, and we have an FBA, FAB, let's call it, and that is at 15 degree here. So this has to be 75 degree. Okay, I hope this free body diagram is clear to everyone. This is you can call it as RA. Okay, so RA divided by 105, sine of 105 is equal to W divided by sine of 60 plus 75. That is equal to FAB divided by sine of 120. Okay, so this will give you FAB value, because W you know that is how much, 600. So I'll directly write here 600 Newton. The FAB will be equal to 600 sine 120 divided by sine of 135, and that will be 734.85 Newton. Okay, um, so we are not interested in RA and all, because we need FBA because if you draw the free body diagram of second roller, you need FBA there. Okay, that is the only reason I calculated FBA. So I will not waste time in calculating RA here. Okay, so we have an 45-degree angle. 45-degree angle, we have the RB. Okay, so this is also 45. At P is acting at 70 degrees, so this is 30 degree. Weight is acting in downward direction. W. Calculate here, because we cannot apply the let's here only, so make it easier. W is equal to 400 Newton. And any other force? Yes, FBA. F ए बी ये 15 है एंड ये 75 है, ठीक है, और दिस इज 90 as So that's all. Then apply the summation h equal to 0, summation v is equal to 0. Equation of equilibrium. Summation h equal to 0, FAB cos of 15 minus P cos 30, okay, um, minus RB cos of 45 equal to 0. Okay, so from this you will get a relationship between P and RB. 0.94P plus 0.707 RB is equal to ABA. We just calculated 734 multiplied by cos of 15, it is 709.865. Okay, let's call this as equation number 1. Summation of all vertical forces. Yes, sorry, it's 20. Let me check it. What is cos of 20? Cos of 20, 0.93. So it's, yeah, it's fine, 0.94. Okay, let's call it as equation number 1. 93 something, so you can keep 94 as well. Then summation of all vertical forces equal to 0. Then you will get minus so W is acting downward, minus 400 minus P sine of 20 minus FBA sine of 15 plus RB sine of 45 equal to 0. Okay, and from this also you'll get a relation in between P and RB, 0.342P minus 0.707 RB. The R is equal to minus 590.326. Okay, this is an equation number 2. Solve these two simultaneous equation, and or you can just add them. If you add them, this will get cancelled. RB 0.94 plus 0.342, that is 1.282. Okay, 1.282, and numerator, so RB will be equal to 709.865 minus 590.326 divided by 1.282. So it is close to 119.539 divided by 1.282, and RB will be equal to 93.24. So force P you can put back into the equation and get, you should get it as 93.24 Newton is the correct answer. Oh, sorry, no, this is force P itself, because RB is cancelled. Yeah, sorry, this is force P itself, because the RB term we cancelled, so the P is what we are calculating. 93.24 Newton is the correct answer. Any doubt in this question? See, if you see, all 3 problems are more or less same. Nothing is different in 3 problems. You just have to calculate the free body diagram. And write the angles correctly. Yes, Shrujana. What is your doubt? Are you everyone understanding this free body diagrams? Anyone have any doubt in this free body diagrams? Please let me know. Because if it is clear to you to draw the free body diagram, this is nothing. This is just a summation of all horizontal forces and vertical forces equal to zeros. That anyone can do this. You should understand mainly how to draw the free body diagram. Okay. Okay, let me repeat it for those who didn't understand it. So they are asking this force P. Okay. We are asking this force P to calculate. But in order to calculate this force P, like when you draw the free body diagram of this, there are three unknown things. One is P, one is this reaction because of this support RB, okay, and one is this FBA, okay, the force in the member AB, and only known thing is WB. So three unknowns, and you can create two equations: summation of all forces in y direction, x direction equal to 0. If you have three unknowns and two equations, you will not get the answer. Okay, so in order to remove one unknown, you have first drawn the free body diagram of this block of this roller A, and then calculated the FBA, because here the only unknowns are FBA and this RA. Here also you can create two equations, okay, or by using Lamy's theorem you can easily get the FBA. Okay, if you don't want to use it, if you want to use summation F equal to summation of horizontal force and vertical forces equal to 0, that's also correct. You will get the FBA using that logic as well. So now you know the FBA. Now the unknowns are only two, that is P and RB, and we have two equations coming from summation of horizontal forces equal to 0, summation of all vertical forces equal to 0. Okay, and using these two equations you will get the value of P. Is it clear, Surjana? Yeah, okay. So looking at your pace of solving these questions, I will give you one homework question. Okay, one or two homework questions. You try to solve it, or maybe I'll give it later, because it will take some time to write it and draw the figure. It's better to spend time on solving the questions now, and I will give this homework questions later in WhatsApp. Okay. Um, yeah, but one question will solve again of the similar type. I would expect correct answer this time. Okay. Two cylinders, each of 50 centimeter diameter and weighing 1.5 kilonewton, rest on a smooth horizontal surface. They are connected by wire rope. Connected by wire rope at their centers. Of length 60 centimeter. Third cylinder of 80 centimeter diameter, weighing 2 kilonewton, rests on the lower cylinders. Okay, find the tension in the wire and pressure between contacting surfaces, or reaction you can say between contacting surfaces in kilonewton. Okay, the answer should be in kilonewton, both the answers. One is tension and this pressure. Let me help you out with the diagram. So two cylinders, one Mm, okay, these are the two identical cylinders of 50 centimeter diameter. Okay, and weight is 1.5 kilonewton. Okay, um, and then we have this big roller. Okay, uh, yes, and this is of 60 centimeter. Sorry, this is of how much? 80 centimeters. Okay, this is of 80 centimeter mm, diameter, and weight is 2 kilonewton, and they are connected by using wires. This is 60 centimeter. Okay, yeah, I hope it is clear now. So the wire is connected only here. Okay, listen carefully. This is the only part where the wire is connected, and here just I'm drawing this center lines. Okay, the red portion is wire. Okay, I'll repeat the question if it is not clear to you. Two cylinders, each of 50 centimeter diameter, weighing 1.5 kilonewton, shown here, rest on a smooth horizontal surface, and they are connected by a wire rope. Okay, at their centers of length 60 centimeter. The third cylinder, 80 centimeter diameter, weighing 2 kilonewton, rest on the lower cylinders. Okay, as shown in this figure. Find the tension in the wire and the pressure between the contacting cylinders. So draw the freeboard diagram and solve it. The main task here is to draw the freeboard diagram. If it is, if you are able to draw the freeboard diagram, then there is nothing. Then there is nothing else to solve. It is very, very easy. Yeah. Yeah. After this, we have to solve a couple of questions on friction as well. So do it fast. Drawing a freeboard diagram is main task here. Okay, let's solve it. I will help you with the freeboard diagrams. So if you look into the freeboard diagrams of small roller, okay, you can post your answers if you are done. Okay, P is in this direction. Let's call this point as point P, this point as point again P, because same force will be there. Okay, and we can call this point A, B, and this as a C, and here it as a D. Okay, so let's call this as a P, which is at an angle theta. We are applying some force. Then here we have a tension in the string. Weight is acting downward, W. Okay, same is here. Weight is acting W, WB. Okay, tension here is in this direction, and we will have P in this direction. Okay, P is the pressure between the surfaces, which we are supposed to calculate, and that is at angle theta. We don't know as of now. Okay, so what is theta? This is theta. Okay, this is theta, and this is also theta on the right hand side because it's a symmetric figure. So you can calculate theta angle by what is the sine theta? Sine theta is equal to perpendicular divided by hypotenuse. Perpendicular is 30. Hypotenuse is sum of the radius of the two cylinders, 25 and 40, right? So theta is equal to sine inverse of 30 by 65, which is 0.462. You will get theta is equal to 27.49 degrees. So you got the theta value. So you know at what angle these are acting. So let's call it as 27.49, and this is also 27.49. Okay, you can also draw the freeboard diagram like this. WB 27.49. You can remove this if you want. Okay, and here also you can draw it like this, P, and this is 27.49. Okay, and now you can apply the Lami's theorem. P divided by sine of how much? Or yeah, let's keep it as it is. Maybe as of now it is not needed. Anything is missing here? Yeah, I think two things we have missed as of now. That is reactions. Let me check. Yes, Srujana, I forgot to draw the reactions. Thank you for reminding. RA and RB. Okay, and we don't know the values of RA and RB also. So, but obviously it's a symmetric figure. The value of RA and RB we expect to be have same. Okay, so R is the reaction will be equal to total weight divided by 2. Okay, what is the total weight of the system? 1.5 plus 1.5 plus 2, correct? 2 is the weight of the bigger block, so divided by 2, so it is 2.5 kilonewton, and that is upward. Okay, Ra equal to Rb equal to R. Okay, is it clear? Yes, 1.12 is the correct answer, Abhishek, for P, and tension in the rope looks incorrect. Okay, what is your doubt, Abhishek? What you didn't understand here? How you are asking? What is your doubt? See, 2 kilonewton is the weight of the bigger block, right? And 1.5 and 1.5 kilonewton is the weight of these two blocks. So total, how much weight we are applying on the ground? Total, we are applying 1.5 plus 1.5, that is 3 plus 2, that is total 5 we are applying on the block, okay, by let's say. And how much reactions we have? We have two reactions and they are symmetric, right? So total weight downward is let's say 5 kilonewton. So two upward reactions which is in the symmetric figure should be half of the 2.5, okay, half of the 5, so that is 2.5. That is why it is calculated like this. Yes, okay. So you can draw the free body diagram of the bigger block, bigger cylinder as well. The bigger cylinder, how the free body diagram will look like is this. We have weight which is acting downward, 2 kilonewton. We have force P, and you have one more force P. And the angle also you know, which is this is theta angle. We have already calculated. Okay, so you can directly apply the Lami's theorem, P divided by sine of how much? 180 degree minus theta. Yeah, sine theta itself. And that is equal to WC divided by sine of 2 theta. So P you can calculate from here. WC is 2 into sine theta divided by sine of 2 theta. That is equal to 2 into 0.462 divided by 0.819, and that is 1.128 kilonewton. So P is correct. Abhishek, you have calculated correctly. About the tension, yeah, you can use any of this free body diagram and calculate the tension. So what will be the tension? Tension will be equal to sine component of the P. So that is P sine of 27.49. Okay, and that is equal to 1.128 into sine of 27. We already know this number. Sine of 27.49 is what? 0.462, and that is 0.52 kilonewton. Okay, so the tension in the rope is 0.52. Webho, are you following? Punya? Okay, so I hope it is clear to you all. If you have 0.68, what is that? 0.68? No. Let me just check the calculation. Others, is it correct or wrong? 0.52 is the correct, Sujana. You just multiply this, right? So you know this sine of theta, okay, or sine theta was equal to 0.462. So sine of 27.49 is 0.462. That is what I have used, and P we just calculated. So just check your P. If it is correct, then the answer should be 0.52. Okay, Abhishek, 0.516, yeah, more or less very close to 0.52. It's not a problem. Okay, so I hope it is clear to you. Some questions I'll send you to WhatsApp, okay, in which you have to apply the similar approach. Let's solve one or two questions from the friction topic, as we have some more time. Okay, so this is the question. A block of weight 6 kilonewton and coefficient of friction between the table and the block is, so block A is here, which is 6 kilonewton. Coefficient of friction is here 0.25. The find the maximum weight of block B. So here weight you have to find WB, WA. Um, and what they are asking is they are asking first is WA. What is WA? Sorry, WB. And second question is also determine tension in the cable. Also tensions in the cable. Tensions in the cable. So there are like two tensions. You have to calculate it. Yes, Abhishek, we can arrange a doubt clearing session later. Yeah, but you can feel free to let's say use the WhatsApp group. What we can do is if we have more doubts, then we can collect them, and then we can have a doubt clearing session. Okay, if we have session and then maybe you will ask some questions there, then it will take time, because you will first tell the question, we will write it, and then um, basically it will be time consuming. So what we can do is if you have any conceptual doubt, we can cover it, let's say in a one session. We can arrange a doubt clearing session where if you have any conceptual doubt about any of the topic in this subject, we can cover it. But if you have doubts in some problems, okay, I would say like the best way is to make use of WhatsApp group. If you post there, if you are not able to solve, others can, some other student can be can know the solution, or I can also help you with that. Okay, so if you have any specific doubt related to some problem, better to use the WhatsApp group. If you have any conceptual doubt, you can approach me. I'll collect the doubts, and then we will arrange a we'll arrange a doubt clearing session. Is it clear, Abhishek? Yeah. So whenever you are revising the subject, and if you have any doubt, just ping me on WhatsApp, okay, and I will make a list of it, and I will ask Dinesh sir to arrange one session later once we have enough topics to cover in a session. Okay, so yeah, looks like some of you have already answered it, right? The tensions are 1.5, yeah, and 2.12, and weight is how much? 1.5. Yes, correct. Yes, most of you answered it. Then let's do it quickly. So if I draw the free body diagram of block A, how it will look like? Weight is acting downward. W, that is 6 kilonewton. Normal reaction is upward. Coefficient of friction mu. So frictional force is in the left hand side direction. Mu into Na. And on right hand side we have tension 1. Okay, T1. So what is the value of T1? Na will be 6 kilonewton. 0.25 into 6 is 1. How much? 1.5? Yes. So T1 is 1.5 kilonewton. Let's draw the free body diagram of this joint. You can call it joint C. We have WB acting downward. We have tension 1 acting this side, and we have tension 2 acting this side, making an angle 45. So using Lamis theorem, W divided by sine of 135, WB divided by sine of 135 is equal to T1 divided by sine of how much? 90 plus again 135. that is equal to T2 by 90. So T1 we have just calculated, that is 1.5. Okay, and from this you should be able to calculate WB. WB is equal to 1.5 because 135 will get cancelled, and T2 will be equal to okay will be equal to 2.12 kilonewton. Clear? Any doubt? Okay, good. um, yeah, WB is clear. You can just cancel it out, and WB is equal to 1.5 as it is. Okay, so it's good. Most of you are solved. Next question can take is this. Okay, we have a figure like this. We have one block, block B. We have another block, block A. It's attached like this. Okay. If okay, so I'll read the question. The two blocks A and B, weight of block A is 100 Newton and weight of block B is 150 Newton respectively. Okay. Find the smallest value of force F required to move the block. Required to start moving the block. Okay. Okay. This is the first question. Second question. When the string is removed, okay, this string, you can see the block. We are attaching one string to the to this. When the string is removed, the coefficient of friction between the floor and the block B is okay. In both the situations, you have to find when string is there and when string is removed. So this is a B situation. A situation is when the string is there. Okay, coefficient of friction between the floor and the block is 0.25, and between the two blocks is 0.2. Okay, I hope things are clear. I'll repeat it once again. Listen carefully. Two blocks A and B. Block A is 100 Newton, block B is 150 Newton respectively, and what they're asking, the smallest force F required to move the block. In first situation, when the string is there, and second situation, when string is removed. Okay, and the coefficient of friction is 0.25 between the floor and the block B, and in between the two blocks, the coefficient of friction is 0.2. Okay, the data is given to you. Make a use of it and solve the question. So situation A, when string is removed, it is 62.5. Correct. So okay, so let's say A string is removed and B is string is so start with A. String is removed. When string is removed, problem is easy because you can assume it as an entire system. Okay, like this. This is 100, this is 150 NB, and the frictional and the force F is applied here. Frictional force is here, mu B NB. So in this case, summation of Y is 0. So NB will be, in this case, directly you can say 250 Newton. Okay, and the summation of all forces in x direction, if you do 0, then the force is equal to only the frictional force, that is 0.25 times the NB, that is 250, which is 62.5 Newton. So when you have the, let's say, string is removed, then that time problem is simpler. You can assume entire as one system, and when you pull the below block, the automatically system will be pulled. Okay, so when you put the string, obviously you have to apply more force, because you will have one frictional force on top surface as well, coming from the block A. Yes, Abhishek, your answer is correct. 82.5 is the correct answer. So in that case, you may have to draw the two free body diagrams. Okay, so let's start with the body A. So the string is present. Okay, this situation now we are studying. So we have body A. Tension is applied to the body. We have mu A and A. Okay, we have weight of the body 100. We have Na, force acting upward. Okay, so here Na is equal to 100 Newton. You can also write tension will be equal to 0.2 times 100, and that is 20 Newton. Okay, this is from the first figure. From the second figure, block B, you have one Na force here. Okay, you also have the weight W downward, but you have one upward force, that is Na I will write here, and NB I will write here. Okay, this is how it will look like. And then we have mu B NB, sorry, forces here, mu B NB, and here forces in this direction, that is mu A NA. Is it clear, the free body diagram? So if it is clear, then let's draw summation of all y is equal to 0. So W here is 150. So NB is equal to 150 plus Na, that is 150 plus 100, that is equal to 250. All right, so NB is equal to 250 Newton. Now the summation of all x forces equal to 0, so F is equal to mu ANA plus mu BNB. Mu ANA we already calculated, that is 0.2 into 100, that is 20. Mu B we already know, that is 0.25, and NB is 250 we calculated, so it is close to 65, 62.5, sorry, and plus 20 is 82.5 Newton. Okay, so yeah, practically also, if you think that whenever we have a string, obviously we'll have one restriction to the movement of the block B because of the friction in between these two blocks, and it will indirectly affect you to pull the block B with a more force, okay, compared to if you remove the string. I hope the question is clear to you. We have solved similar question before. Yeah. So, yeah, I'll give one homework question to you. You can try it later. Write down it quickly, and we'll end the session. Okay, we have these two blocks. Sorry. Yeah. Okay, I hope you understand the figure now. We have 50 kilonewton block and we have 5 kilonewton block. They are placed like this, and we are applying force P here. Angle is given, which is 15 degree. Okay, the question here is, the block of weight 50 Newton is kept in equilibrium by a wedge shown in this figure. If the coefficient of friction is 0.2 for all contacting surfaces, the wedge has the weight 5 kilonewton, okay, as shown in the figure. Determine force P necessary to cause a tendency of block to move up. So how much amount of force P we have to apply in order to just start moving the block upward? Okay, so P is what they are asking. Mu is given as 0.2 for all contacting surfaces. This is your homework question. You try it, and if you face difficulty, feel free to reach out to me. Okay, answer here is 39.53 kilonewton. Okay, if you draw the pre-body diagram, the question is quite easy. It's not that difficult. Okay, so write it down, and we will end our session here. So as I said, if even if the subject is completed, you are feel free to contact me on WhatsApp. I have given you my WhatsApp number, and you can make use of our group. You can put your questions. Okay, if don't waste time. If you let's say are tried it once or twice, directly post it into WhatsApp group. Some other students will help you to answer it, or I will also help you to answer it. If you have any conceptual doubt, you can directly approach to me on WhatsApp. Okay, we can have a discussion over a call or over a chat, and we can clarify it. Okay, but if you have like little more doubts, then we can also arrange a doubt clearing session. Okay, so with that, let's end our session here. Thank you all for joining this, and as I said, keep your hard work for this year. It will give a very good result if you continue your pace, and do not lose the pace of your study during your last few months. Okay, that's my suggestion to you. Whatever you are doing now, it's good, it will help you a lot, but this pace you have to continue till end, till the exam. Okay, do not lose the concentration, rather you have to increase your time for study and the pace during the last few months. Okay, they are very important. So with that, thank you all for joining this session, and have a good luck ahead. Bye.